Hi students, in this video I'll be going through the 2014 O-Level Mathematics Paper 1 question 20. Right, so let's read the question. So the diagram shows a spinner with 8 numbered sectors. Each time the pointer is spun, it's equally likely to stop on any of these sectors. So the pointer is spun once, find the probability that it stops on an even number. So over here they want us to find the probability of the pointer stopping on an even sector, right? Okay, so probability of even. So we know that to calculate the probability of a particular event, in this case getting an even number, we will need to take the number of even sectors, okay, number of even sectors, and divide it by the total number of sectors, right? Total number of sectors. Okay, so over here, if you look at the diagram, there are actually two even sectors, 2 and 4, and the rest are odd, right? So the probability of getting an even would be 2 out of total. There are 8 sectors over here, 2 out of 8. So we always put the answers to the lowest term, so it will be 1 over 4. Okay, so the answer for part A will be 1/4. So let's read part B. Okay, Anil spins the pointer twice. Okay, so now that this person Anil, he's going to spin the pointer 2 times. So find the probability that the pointer stops on an even number both times. Okay, so he spins 1 time. Okay, then he looks at the number. Okay, so now in this case, he wants it to be even. And then he spins it 1 more time. Okay, and then now he wants it to be even again. So what is the probability of that happening? Right, so now it's making 2 spins. Right, so probability, both spins are even. Okay, both even. Okay, so let's write out the possible outcomes for this. Okay, so to have both spin even, right, there's actually only just one possible outcome. Okay, which is the first spin is even, and okay, the second spin is also even. Okay, second spin is even. So both the first and the second spin must be even. All right. So this is a case of n. Okay, so you just have to remember that whenever it's an n case, right? Okay, it will be a product. Okay, all you need to do is take the product of the first spin being even. So the first spin being even, we have already calculated in part A, right? Okay, the probability of having a even number for a particular spin is 1/4. Okay, so whenever you see this word n happening over here, is per product, so it will be times, all right? And then the probability the second spin is even, okay, will also be 1/4 because each spin is independent of one another. Okay, the result in the previous spin doesn't affect the result of subsequent spins, right? So it's going to be 1/4 times 1/4. Okay, so it's going to be 1 over 16. Okay, okay, so it's going to be 1 over 16. Okay, so I repeat again. For both even, there's only one possible outcome, which is the first spin is even, and the second spin must also be even. Okay, so if it's an n case, then it will be times, all right? It will be times. So the probability of the first spin being even is 1/4 times the probability of the second spin being even, also 1/4, you will get 1 over 16, all right? Okay, so let's take a look at part C. Okay, there's another person, Rin, who spins the pointer twice. Okay, but now the way of playing the game is different. Okay, what she's going to do is she's going to add up the total points from both of the spin. Okay, the total score from both of the spin. So find the probability that her score is not 2. Right. So if you look at this board, okay, not 2, right? Okay, what are the ways to get not 2? Okay, not 2 maybe the first spin is 1. Okay, then the second spin is 2. Then 1 plus 2 is 3, right? Not 2, right? Okay. Then it could also be possible first spin is 1, second spin is 5. Then 1 plus 5 is 6. It's not 2 also. Okay, then you can also go for 1, 4, 1, 3. Okay, maybe 3, 4, 3, 2. Okay, 3, 5. So as you can see, if we are going to list out all the possible outcomes for not 2, right? Okay, over here we want probability not 2. Okay, if we are going to list out the possible outcome, it's going to be a lot of possible outcomes, right? So if you think about this, okay, whenever you have a case whereby you need to list out a lot of outcomes, right? Okay, I want you to think about the complementary case, okay, or complementary case. Okay, if you look at this diagram, okay, we want not to, right? Okay, how about if I rephrase the question? What is the probability of getting a 2? Okay, if you think about it, the only way to get a 2 is first spin is 1, second spin also 1. Okay, then you are going to get 2, right? Correct or not? Okay, so to get a outcome of 2, there's only one way to get it, which is 1, first spin is 1, second spin is also 1. Okay, so there will be probability of getting a 2. Okay, so to calculate the probability of not 2, instead of listing out all the outcomes for not 2, I will use the complementary case. I will use 1 whole, okay, which is the probability of all the outcomes minus the probability of getting a 2, okay? The 2 for the total score. Okay, then in this case, right, okay, as we've discussed earlier, the probability of getting a 2 for the total score, there's only one way, okay, which is first spin, okay, is 1 and second spin is also 1. Okay, so there's only one way, okay, to get a 2 for the total score. Okay, this way is going to be very easy to calculate. Okay, so what is the probability of the first spin being 1? Okay, how many 1s are there on the board? 3, right? 3 outcomes that favor 1 out of the 8 outcomes, right? So the probability of the first spin is 1 would be 3 over 8. Okay, again, this is an AND case. Whenever you see an AND case, means it's a times, alright? The probability of the second spin is 1 will again be 3 over 8. So from here, we will be able to calculate. So 1 minus 3 over 8 times 3 over 8, you will get 9 over 64. Right, so 1 whole minus 9 over 64, you're going to get 55 over 64. Okay, so the answer for this part, C is going to be 55 over 64. Okay, so I just recap on this part. Why did we use a complementary case? Okay, because we want to calculate probability not 2, and to list out all the possible outcomes for not 2 is a lot. Not 2 could be 1, 2, 1, 3, 1, 4, 1, 5, okay, 2, 3, 2, 4, 2, 5, okay, 3, 3, 3, 4, 3, 5, and so on. Okay, so there's a lot of possible outcomes. Okay, but the probability of getting a 2, there's only one outcome, which is first spin is 1, second spin is 1. Okay, so since I want not 2, I will just take 1 whole minus the probability of getting a 2, okay, for the total score, and that will give me all the possible outcomes really. Because if it's either 2 or not 2, right? Right now, it's either you get 2 or your score is not 2. So if I take 1 whole minus the probability of getting 2, then I will get the probability of not 2. Right? So this is the method to solve a question whereby there's a lot of possible outcomes for the outcome that you want. In this case, not 2. Right?